So next we will see when are two complex numbers equal. Now remember I had told you earlier, a complex number is made of a real number A and an imaginary number B and I. And think of this real and imaginary part as two different parts, like oil and water, which don't mix, or like oranges and apples. So if I now give you two complex numbers, Z1, which is A plus BI, and Z2, which is C plus DI, think of it as two baskets with Z1 and Z2. And I say that both these baskets are exactly the same, which means the number of apples in this basket should be same as the number of apples in this basket. And the number of oranges in this basket should be the same as the number of oranges in this basket. So which means two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal also. That means real part of Z1 should be equal to the real part of Z2, and the imaginary part of Z1 should be equal to the imaginary part of Z2. It's as simple as that. Let's move on and now talk about the properties of complex conjugates. So I hope you remember we had talked about complex conjugates earlier. If I have a complex number Z1, which is A plus BI, then its complex conjugate Z2, or I should write as Z, should just write this as Z and Z with an asterisk. If Z is a complex number A plus BI, then its complex conjugate is written as Z with an asterisk on top, and that is A minus BI. So for example, if Z is 3 plus 7i, then Z conjugate is 3 minus 7i. And let's perform a few calculations here to investigate the properties of the complex numbers. Now, if I have this complex conjugate Z conjugate as 3 minus 7i, and I want to take the conjugate of this complex number, 3 minus 7i. If I want to take the conjugate of this second complex number, then what should it be? Remember, in a complex conjugate, the coefficients remain the same, but the sign in front of the imaginary part becomes opposite. So if I have 3 minus 7i, then the conjugate of 3 minus 7i will be 3 plus 7i, which is the same as this complex number Z. That means Z conjugate of the conjugate is same as the complex number itself. And that's the first property of complex conjugate. Conjugate of the conjugate is same as the complex number Z. Next, let's try to add the two conjugates. Or let's try to multiply them. Z multiplied with Z conjugate. So if we take the same example, 3 plus 7i, Z is 3 plus 7i, and Z conjugate is 3 minus 7i, then recall the multiplication of two complex numbers. 3 times 3 is 9, minus 21i, plus 21i, and minus 49i squared, which is plus 49. And what we get is the imaginary parts cancel out. We get a purely real number. 49 plus 9 is 58. 58. So Z multiplied by Z conjugate is 58, which is a real number. And you can try this with any complex number and its conjugate of your own choice. Give it a try. Maybe you might want to try with minus 4 plus 5i as a conjugate number, and as a complex number, and its conjugate minus 4 minus 5i. Multiply these two and see if you get the same result, that Multiplication of a complex number with its conjugate results in a real number. Next, let's try to add these two conjugates, z plus z conjugate, z plus its conjugate. Since z is a plus bi and its conjugate is a minus bi, no matter whatever we take as a and b, the imaginary part cancels out and we get a real number, 2a. So that gives us a third property that if you add a complex number with its conjugate, you will get a real number, which is 2a in this case. There are a few other properties of complex numbers, which is if you add two complex number and take its conjugate, it is same as adding the conjugate of each of this. z1 plus z2 conjugate is same as z1 conjugate plus z2 conjugate. Let's try this. Say z1 is 3 plus 4i and z2 is minus 4 plus 2i. And let's try to add z1 plus z2. We'll get 3 minus 4, which is negative 1, and 4i plus 2i, which is plus 6i. So then what is the conjugate of z1 plus z2 conjugate? It's minus 1 minus 6i. z1 plus z2 is minus 1 plus 6i. So its conjugate will be minus 1 minus 6i. If z1 is 3 plus 4i, then what is z1 conjugate? It is 3 minus 4i. And what is z2 conjugate? It is minus 4 minus 2i. Let's add z1 conjugate with z2 conjugate. 3 minus 4 gives us negative 1. And negative 4i, negative 2i gives us negative 6i, which is the same as z1 plus z2 conjugate. Hence, proven. Another property of the conjugates is z1 times z2 conjugate is same as z1 conjugate times z2 conjugate. Now take the same values of z1, z2, and z1 conjugate and z2 conjugate to test this investigation by yourself. One last property of complex number and its conjugate is, if you take a complex number raised to the power n and you take the conjugate of this, is the same thing as raising the conjugate to the same power. So let's summarize all the properties of the complex number and its conjugate. Property 1 is z conjugate of z conjugate is same as z. Property 2, z plus z conjugate is a real number. And maybe I can just write it as r. Property 3, z multiplied with z conjugate is also a real number, always. Property 4, z1 plus z2 conjugate is same as z1 conjugate plus z2 conjugate. Property 5, z1 times z2 conjugate is same as z1 conjugate times z2 conjugate. And finally, last property, z to the power n conjugate is equal to z conjugate raised to the power n.